past, we have learned that there is actually tremendous value in representing data graphically, because you can look at it and in a glance you can see, there's this trend, or this bar over here is achieving high, or this pie chart is very evenly distributed. And so there's a nice fair spread of data. And so because there's such value in representing data graphically, it is an important section of our statistics syllabus. And so today we are going to look at one of the ways that we can represent data that can give us a really good summary of a whole lot of data just in a glance. So up until now, we've looked at things like line graphs, bar charts, histograms, pie charts. Today, we are going to look at the box and whisker plot. So this over here is a box and whisker plot. It is made up of what we would call the box, and then two little lines that extend out, and we call those whiskers. This is a great way to get five facts about data in a heartbeat. And those 5 things are known as the 5-number summary. The first thing that we can read from a box and whisker plot is the minimum value. So this end of the whisker here is the minimum value. And then you can probably guess that the whisker on the other side there ends with the maximum value. So we've got a minimum and a maximum value. And then the box is actually represented by quartiles. So quartile 1 is the edge of the box. Quartile 2, also known as the median, that's the middle line in the box. And quartile 3 forms the outer boundary of the box. So the 5-number summary, if ever we are asked to work it out, we need to calculate the minimum score, or at least write it down. We don't necessarily have to calculate that. Quartile 1, which remember is a quarter multiplied by n plus 1. At least that's the position of it. It's not the actual quartile. Okay. Quartile 2, which is the same as the median, a half times n plus 1. There tells us that location. Quartile 3 is 3/4 times n plus 1. And finally, the maximum score. Okay. And in each case, like I said, this little formula here tells us the position within the data. Something worth noting, because they like to ask it, and they like to ask it in grade 10 and grade 11 and grade 12, is that regardless of what this looks like, it might seem like there is more data here than here, because this box is smaller than this, okay? But it is essential to know that there's the same amount, equal amounts of data are represented by each section here of this, okay? 1/4 of my data values sit there, 1/4 sit there, they are clustered together, 1/4 sits here, they are more spread out, and the other quarter sits here. So if ever you get asked any question about that, like how many data scores sit here, or what percentage of people scored above this, then make sure that you either break it down into quarters or 25%, and then answer those questions very carefully. Okay, let's try an example, put our knowledge to the test. Okay, here we have a whole lot of data. Determine the 5-number summary for the data above. That's question 1. Question 2, draw a neat box and whisker plot to represent this data. Okay, the first thing I do, grade 10s, is I check, is this data in ascending order? Because if it isn't, I'm going to have a hard time working out the mean or the median and the quartiles, all that stuff. Okay, so it does go from smallest to biggest, so we are safe. The next thing I want to know is how many scores there are, because that's going to help me here with my 5-number summary. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 scores represented there. Okay, and now I'm ready to tell you things about this 5-number summary. Okay, what are the things I need? Let's see if you can remember. The minimum and the maximum, we'll get there. Quartile 1, quartile 2, quartile 3. Let's call this also the median. And then finally, the maximum. Okay, there we have those. Let's give them different representations. Okay, So to get the minimum, I just look at my data and I can see it. Smallest value there is 5. To get the maximum, the largest value there is 47. Now, to get each of these other ones, I need to first of all work out where are they located. So a quarter times n plus 1. That's why I wanted to work out how many scores there are. 15 plus 1 is 16. A quarter of 16 tells me it's in the 4th position or 4th location there. Okay, the median then will be a half times 16, so in the 8th location there. And finally, 3/4 times 16, the 12th. Okay, and that really helps me because now I can say, well, quartile 1 is the value there in the 4th position, 14. Quartile 2 is the value in the 8th position there, 21. And quartile 3 is the value in the 12th position there, 31. Okay, not too bad. That is my 5-number summary. Now they want me to draw a box and whisker plot. And so what I have seen in the past is my students grab their pencil and they do this and they just write down these things: 5, 14, 21, 31, and 47. Okay, you are going to get very few marks for that because it is actually not a good statistical representation. I cannot accurately make a call about what kind of data I'm looking at. And so the first thing that we need to do when we are given a box and whisker plot to draw is draw a number line. So my data goes from 5 all the way up to 47. So I could probably go up in 2s on this number line. So 0, 2, 4, 6, 8, 10, and so on. Now I can draw a very neat box and whisker plot because I've got a number line to base it on. So when they say to me, okay, the minimum, or when I say to them, because I'm the one drawing it, the minimum is 5, then over here between 4 and 6, I can plot a neat little dot. Then quartile 1 is at 14. Remember, quartiles we draw with lines. Please use your ruler. Okay, quartile 2 is 21, so between 20 and 22 there. Quartile 3 is 31, so that's going to go over there. And finally, the maximum here is at 47, and we'll plot that. And then we'll use the ruler to close this box and whisker plot. There we go. Now I've represented it as a box and whisker plot. But let's take a moment to have a look at why this is valuable. Because actually, simply by looking at this, I can tell you quite a bit about this data. But let's first look at why. A box and whisker plot is a way of representing my data in quarters. So a quarter of my data sits here in the lower tail, a quarter of the data in the first box, a quarter in the second, and a quarter in the last. Okay, and so by looking at how squashed up my box is, it tells me how clustered together my data is. Okay, and so simply by looking at this, I can interpret what is known as the skewness of the data. Okay, if you see that you've got your data clustered together here on the left and the tail extends very far out to the right, then that is known as data that is skew to the right. Okay, it's also known as positively skewed. And then just for interest's sake, I've added the mean here so that you can understand it. If the median is smaller than the mean, then your data is skewed to the right. Okay. In the second example there, you'll see the opposite is happening. The tail, the long tail, the more spread out data is happening on the left. So this is skewed to the left, okay, which is negatively skewed. And in that kind of data, then we have the fact that the median is actually bigger than the mean. Then your data is skewed to the left. Or you have what every statistician dreams of but never gets, and that is where your data is symmetrical. Okay, in other words, everything is spread out perfectly. All of the 25% are allocated exactly an equal amount of space. Okay? And the mean is equal to the median. So if ever you get asked to interpret some data, have a look at the box and whisker plot and decide, are the values clustered very low down? Then it is positively skewed. Are the values clustered rather on the upper end? Then it is negatively skewed or skewed to the left. Here's one last example. Let's see if we can interpret some data based on a box and whisker plot. So the box and whisker plot represents Danielle's scores out of 50 for 20 different dance routines over the past 6 months. Determine the range and interquartile range for Danielle's scores. Okay, so what do we know? Range, grade 10s, is maximum minus minimum. And so we're just going to work that out. The maximum value there from the box and whisker is 49, minus the minimum is 7. So 49 minus 7 is going to be 42 points. Okay. Then the IQR, that means interquartile range. Okay. So IQR is simply Q3 minus Q1. Okay, so quartile 3's value there, based on my box and whisker, is 41. And quartile 1's value there, based on my box and whisker, is 17. So 41 minus 17 gives us an answer there of 24. So 42 points for the range, 24 points for the interquartile range. Remember, if you had any outliers, then you're better off going with interquartile range. Now, how many scores did Danielle get between 17 and 41? Okay, so this is an interesting question because they're not asking us the interquartile range. They've just asked us that. They've asked us how many dance competitions did she score in this space here? Okay, now what do we know about box and whiskers? We know that our data is divided into 4 quarters. So 25% of Danielle's results were here, 25% here, 25% here, and 25% here. So between 17 and 41, we've got 2 quarters of the data. And so what does that mean? It means 2 quarters of my data is happening between 17 and 41 times by her 20 different dance routines. So in other words, I'm just saying what is a half of 20? Or I can say if I divide in a quarter, 5 competitions she scored there, 5 there, 5 there, 5 there. That could also work. But essentially, I need to come to the answer of 10 competitions happened where she scored between 17 and 41. Okay, and they love to ask this. So try to keep your head about you. Don't complicate the question. They are generally checking that you understand that 25% of your data is represented by each section of this plot.